EMU is an all-encompassing musculoskeletal simulation framework that handles joints and preserves volume during muscle contraction. EMU handles stiff tendons and nearly rigid bones. It allows for anisotropic muscle fibers with realistic activation models and realistic material parameters. Current state-of-the-art muscle simulations can be simplified into three categories: standard FEM, data-driven muscles, and constraint-based approaches like projective dynamics. Each of these approaches has limitations which prevent them from being a universal solution. We believe EMU is a one-stop-shop musculoskeletal simulation framework that brings us one step closer to ideal muscle-driven motion. In contrast to other methods that use non-trivial coupling terms to transfer muscle forces to bones, our framework handles muscles and bones in one simple system without the need for any coupling terms. EMU can handle large musculoskeletal systems with anisotropic fibers on multiple muscles. EMU handles external forces such as gravity and can also resolve collisions. Like most other physics simulation problems, EMU boils down to an energy minimization problem. However, the novelty in our framework is that we use the deformation gradients for each element as the degrees of freedom in the energy minimization while visualizing the deformations on the nearest continuous mesh. The nearest continuous mesh is a continuous mesh whose elements most closely resemble the deformation gradient solved for by the energy minimization. On a single core, EMU's performance over FEM increases as mesh size gets larger. However, EMU is easily parallelized, giving it a scalability advantage over standard FEM as well. Finally, here are some more results generated by our method. This is an example of an isometric contraction, where the muscle contracts without moving any bones. Here we show that you can flex opposite pairs of muscles sequentially to move your arms back to a neutral position. This elephant trunk is a boneless muscle. In addition to muscle-activated motion, EMU also allows users to script the position of the bones for custom deformations. Lastly, our method can also be used for non-anatomical geometries. The soft mechanism, as well as this soft gripper.